Okay, so the next thing that I want to introduce to you now is called the commutative property. Okay, let's write that down. Have you ever heard of that before? What comes to mind when you hear the word commutative? Commutative? Okay, that's the first thing, but unfortunately that's not what we want to use in math. Yes?
Compare.
Not even compare. Yes?
Like commuting.
Okay, good. You're getting somewhere. What does it mean to commute? Yes?
To go somewhere.
To go somewhere, okay. And to go somewhere means you have to do what? To go somewhere means you have to do what, Savannah? Huh?
Communicate.
To go somewhere you have to communicate. Now, what is it? To go somewhere you have to do what?
Drive.
Oh, right. Okay, so driving to get you from one place to another, right?
Yeah.
So you are actually doing what?
Commuting.
Say, what is it? Who said something? Say that loud.
Moving.
Moving. Thank you. So the next time when you hear the word commutative, I want you to think about moving. If I don't move anything, it's not commuting, or it's not commutative. So for commutative, it only works for two operations, either addition or multiplication. I'll explain to you why it doesn't work for subtraction and division in a minute. But for additions, this is what I mean by moving. If I take 2 plus 3, will that equal to 3 plus 2?
Yes.
Now go back to that question. Did I move something?
Yes.
Did I? I switched.
Yes.
I switched the 2 with the 3. The 2 used to be in the front, now it's in the back, right? See, it used to be in the front, now it's in the back. And the 3 used to be in the back, now it's in the front. So because I physically move my numbers, that's commutative property. But notice that commutative property is still under the equality property. That means the left-hand side has to equal to the right-hand side. Okay, here's another one. Tell me if I move. Did I move?
Yes.
What did I move?
The 5.
The 5 and the?
Addition sign.
And the 2 plus 3 as well, right? I move something. Because I move, it's the commutative property. Okay? All right. Next one. For multiplication, I shouldn't have to say much because you know that 2 times 3 is the same thing as
3
times 2. Did I move? I certainly did. And it applies the same way. So why won't it work for subtraction? Well, it's the same concept. If you take 3 minus 2, will that be the same thing as 2 minus 3?
No.
No, because they're not the same. It violates the equality property, and therefore it won't work. Same thing for division. If I take 10 divided by 2, is that going to be the same thing as 2 divided by 10?
No.
No, once again, it violates that rule. Therefore, these two, divisions and subtractions, won't work. Don't even think about having the commutative property of subtraction. We don't have that. There's no commutative property of addition either. Of division either. Okay, are we clear on commutative property? Okay, next thing that I want to cover here is called the associative property. So if you look at this right here, associative property also applies to 2 operations only, and that is addition and multiplication. So I mean, for the most part, you can actually exclude division and subtraction out of the picture when you talk about commutative properties, a lot of them. So for addition, what do you think of, when you hear the word associative, what do you automatically think of?
Association.
Association. What else? What is an association, really? A circle of people, right?
Yeah.
So we can say that is a group of people. Is that true? So an association is a group of people, right? So when you hear the word associative, I want you to think about groups. That's it. Group. Okay? Not commutative property anymore, so don't expect anything moving, but expect to have groups. So what do I mean? Watch what happened. Here's my first group. I changed my group. Did I move anything? Numbers. Did I move any numbers?
No.
I asked you very specifically. Did I move any numbers?
No.
See? The question I asked, if your answer is, did I move any numbers? And your answer is no, it's automatic. You should rule out commutative right away. because I did not move any numbers. But what did I change though? I changed the group of my numbers, right? In this group, I have 2 plus 3, but the other groups, I have 3 plus 5. I did not move my number, but I changed my group. Change my group? It's associative. I changed the association, basically. So it's associative property when you see this. So I'm not moving, but I changed my group. That's associative property. But if I actually physically move my numbers, that's commutative property. Okay? Any question on that one? And of course, it's the same way for multiplications. If I have 2 times 3 times 5, 2 times 3 times 5, doesn't matter if I multiply the first group or the last group. But notice every single number stays the same. See it? Different characteristics of our properties here. Any questions at all on associative versus commutative property? Okay? If you have no questions, I have a couple examples to show you to kind of end up in our lectures here. So let's take a look at this one right here. Pretend you have this. Look at that problem. How do you want to solve that problem? Okay, so you start talking about grouping. But before you start grouping what numbers? What number would you group?
8 and 5? 10 and 8.
Thank you for saying 12 and 8. Why do you want to group 12 and 8 together? They're even, it's easier to add, and notice that 12 plus 8 will give you 20. That's easy, right? So the first thing you do is you start, but before you group them, you have to do what to the number? Commute, move it, right? So you have to move the 8 closer to the 12. So we'll look like this. So I'm going to move it closer to the 12, and I'm going to move 10 closer to the 5. Because I moved my number, what property is that? Okay, then you list out, I just used the commutative property of addition, right? Because they're all addition. And then what's the next step now? I add, but I group them, right? So I start grouping them. Is that true? When you're grouping, what is that called? Associative property. So this will give you 20, and this will give you 15. So you know, I just use associative property to get to where I am. And then the last thing is to combine them together to make 35. What property is that? Substitution. Thank you. There's no identity here, right? If you don't recognize the property, most likely it's just substitution, because I just sub 35 into this place. Okay? Question on that one. What do you think? Is that hard?
No.
Okay. Check this one out. I mean, for the most part, you should be able to answer it very easily. Let's check this part. I have this. I asked you to combine like terms. Do you see like terms?
Yes.
What are my like terms?
The
The x squared. The x squared. So basically, you've got to visualize that, hey, I have, right here, I have 3 of the x squared, right? And over here I have 10 of the x squared. They're together, because they look exactly identical, I can group them together. I can use the distributive property to work it out myself by distributing it. So notice this is the like terms part, right? So by undistribute it, I have x squared outside. What do I have left inside?
3.
A 3 and a 10, which makes it 13. And so it becomes 13x squared. Do you see that? Notice your term, the like term stays the same throughout when you combine like terms. See it? It doesn't change. And of course, there is a negative 6x in front. Can I combine that too or no?
No.
So my final answer is just that, because I cannot combine them together. I combine what I can, and then once I'm done, I just write, okay, it's simplified, because I cannot do anything anymore. Question on that? Or this is too difficult to understand? We're good, right?